The solar system we call home is an incredible, vast and majestic place, spanning billions of kilometers. Join us as we take a journey through time and space to learn about the history of our solar system, from its formation to recent discoveries, and everything in between. We will explore the inner and outer planets, and learn about the characteristics that make them unique. Together, we'll uncover the mysteries of our solar system and the science behind the universe. Get ready to experience a fascinating and exciting journey through our solar system. The birth of our solar system began over 4.5 billion years ago, when a massive cloud of gas and dust called the solar nebula began to collapse due to gravity. As this giant cloud collapsed, it began to spin faster and faster, eventually flattening into a disk with a bulge at the center. The bulge would eventually become our Sun, while the rest of the disk would form the planets and other bodies within our solar system. Over time, this cloud continued to condense and heat up, eventually igniting and becoming the star we know as the Sun. This was the beginning of the incredible story of our solar system. The solar nebula was a massive, rotating cloud of gas and dust that contained the building blocks of our solar system. It was made mostly of hydrogen and helium, the two lightest and most common elements in the universe. As the nebula spun, it began to heat up and flatten out into a disk that was denser at the center than at the edges. This rotating disk of gas and dust would eventually give rise to the planets, moons, asteroids, and comets that make up our solar system today. The solar nebula was truly an incredible and massive entity that played a crucial role in the formation of the celestial bodies we know and love today. As the solar nebula flattened into a disk, the particles within it started to come together through a process called accretion. Tiny particles clumped together to form pebbles, which in turn merged to create larger and larger objects. Eventually, these objects became protoplanets, which collided with each other to form the rocky planets of the inner solar system. The gas giants, which are mainly made up of hydrogen and helium, formed much further from the Sun where it was cooler. They grew by attracting gas from the surrounding disk, becoming massive enough to form cores that could attract yet more gas. All of these processes took millions of years to happen, and without them, the incredible diversity and beauty of our solar system would not have existed. In the early solar system, our Sun was surrounded by a vast, swirling disk of gas and dust known as the solar protoplanetary disk. This disk was made up of the same material that formed the Sun and the planets, and it was thought to be relatively short-lived. It is believed that the disk formed as a result of the same cloud collapse that formed the Sun. The rotation of the gas and dust within the disk eventually caused it to flatten out into a thin plane, with the Sun at its center. Over time, small, rocky particles would come together to form larger objects, which would in turn collide with other objects, eventually forming planets. The young Sun was an incredibly active place, with powerful solar flares and coronal mass ejections, CMEs, that would have made life on Earth impossible. During this time, the Sun was also much cooler than it is now, and it took millions of years for it to heat up and become the stable star we know today. As the Sun heated up, it caused the gas and dust within the protoplanetary disk to heat up as well, and this in turn led to the formation of the planets. The Sun's magnetic field also played a crucial role in the formation of the solar system, by helping to create the solar wind that blew away the gas and dust within the disk, allowing the planets to form from the remaining debris. In the early solar system, the building blocks of our planets were small particles of rock and ice. These particles started to clump together through a process called accretion. Small particles came together to form pebbles, which in turn merged to create larger and larger objects. The larger objects eventually became protoplanets, which collided with each other to form the planets we know today. The inner planets, Mercury, Venus, Earth, and Mars, were formed from the solid leftovers of the disk, whereas the outer planets, Jupiter, Saturn, Uranus, and Neptune, were formed from a combination of solid and gas material. As the planets formed, their gravity began to sweep up remaining gas and dust, leaving behind the small rocky and icy bodies we now call asteroids and comets. The four innermost planets in our solar system, Mercury, Venus, Earth, and Mars, have been known since ancient times, but it wasn't until the development of telescopes that we could observe them in any detail. Observations of the inner planets have been ongoing for centuries, revealing new details about their orbits, atmospheres, and surfaces. Today, we have spacecraft orbiting or landed on all the terrestrial planets, allowing us to study them in greater detail than ever before. Out of the four, Earth is the best studied planet due to our presence, but the other three have their own revelations to offer us. The terrestrial planets are so named because of their similarity to Earth, which is made up of rocks and metals. All of the inner planets are relatively small, with Mercury being the smallest and Earth the largest. They are all rocky, with solid surfaces, and are dense compared to the outer gas planets. In terms of their atmospheres, Venus has a thick, toxic atmosphere with temperatures hot enough to melt lead, while Mars has a thin, cold atmosphere with frozen carbon dioxide at its poles. Earth has a dynamic atmosphere with life-supporting conditions, and Mercury has virtually no atmosphere at all. Each of the four terrestrial planets has its unique characteristics that make it an exciting object of study. The terrestrial planets have undergone significant geological evolution since their formation. Earth has the most dynamic geology, with plate tectonics causing the movement of its continents and the creation of mountain ranges. Mars has giant volcanoes and a canyon system that is the largest in the solar system. Venus has experienced episodes of intense volcanism, and its surface is covered in lava flows and impact craters. Mercury's geological evolution is less well understood, but it is known that the planet has a heavily cratered surface due to its lack of atmosphere. Studying the geological evolution of the terrestrial planets helps us understand their history and how planets evolve over time. The outer solar system was first explored by spacecraft in the 1970s and 1980s, with the Voyager missions providing the first detailed images and data of the gas giants. Prior to that, the Jovian planets were known through telescopic observation only. Galileo conducted the first telescopic observations of Jupiter and its four largest moons in 1610, but it was not until the 20th century that observations by spacecraft began to provide detailed information. Today, telescopes on the ground and in space continue to observe the outer planets and their moons, providing us with a greater understanding of their complex systems. The gas giants, or Jovian planets, are vastly different from the terrestrial planets in the inner solar system. They are much larger in size, with Jupiter being the largest planet in our solar system. They are also much less dense, with a composition primarily of gas and ice. The outer planets all have a similar structure, consisting of a small, rocky core surrounded by a thick layer of metallic hydrogen, and then an outer layer of molecular hydrogen and helium. They have many more moons than the terrestrial planets, with Jupiter having over 70 and Saturn over 60. The Jovian planets also have an extensive ring system, which is thought to be made up of icy particles that have been smashed by impacts from passing comets and asteroids. The Jovian planets have dozens of moons each, many of which are fascinating objects in their own right. Some moons, like Io and Europa, have volcanoes and oceans of liquid water beneath their icy surfaces, making them potential locations for extraterrestrial life. Others, like Saturn's moon Titan, have their own atmospheres and weather patterns, making them almost like miniature planets. The outer planets also have an extensive ring system, with Saturn's being the most famous. These rings are composed of millions of small particles, ranging in size from dust to small pebbles, and are thought to be the remnants of comets or moons that were ripped apart by the planet's gravity. The moons and rings of the outer solar system provide us with a wealth of information about the formation and evolution of our solar system. In recent years, researchers have found evidence of liquid water on some of the moons of Saturn and Jupiter, revealing that some of these moons may have life-supporting conditions. Researchers believe that the presence of these subsurface oceans may be due to the gravitational pull of the planets on their moons, which creates heat through tidal forces and melts the ice on the moon's surface. Jupiter's moon Europa and Saturn's moon Enceladus are two of the most promising locations for finding life elsewhere in our solar system, with plumes of water vapor and organic molecules being detected in their geysers. Discoveries of these subsurface oceans have also led to calls for further exploration of these moons to study their composition and habitability in more detail. The Kuiper Belt is a region of space beyond Neptune's orbit that is thought to be the source of many of the objects that make up the outer solar system. In recent years, researchers have made many new discoveries in this region, including the discovery of a dwarf planet called Pluto. In 2015, NASA's New Horizons spacecraft flew by Pluto and provided the first close-up images of the dwarf planet. The images revealed that Pluto has a complex and varied surface, with mountains, valleys, and even a heart-shaped feature. Since then, additional discoveries have been made in the Kuiper Belt, with researchers finding many more dwarf planets and other objects. These discoveries have helped us better understand the formation and evolution of our solar system and the role that the Kuiper Belt may have played in its history. Exploration of the outer solar system has continued with the use of robotic spacecraft, allowing us to discover new details about the Jovian planets and their moons. NASA's Juno mission has been orbiting Jupiter since 2016, providing unprecedented views of the planet's northern and southern polar regions, as well as studying its interior. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, revealed new details about the planet's rings and discovered geysers on its moon Enceladus. NASA's New Horizons spacecraft continues to explore the Kuiper Belt, with plans to fly by another object in 2022. These missions have provided us with incredible new insights and discoveries about our solar system, as we continue to explore and learn more about the world beyond our planet. Thank you for joining us on this journey through the history of our solar system. From its formation to current day, we've learned about the incredible forces at play that created the celestial bodies around us. The discoveries we have made thus far have not only improved our understanding of our own solar system, but also fueled our fascination with the universe beyond. There is still much to uncover and learn, and we have only scratched the surface of what lies beyond. Let's continue to explore the vast wonders of the universe together, and continue to uncover the secrets that lie in the great expanse of space.